Welcome to episode 108 of George's Random Astronomical Object. Every episode, I run a random number generator to select random astronomical coordinates in the sky, and I then search for an astronomical object near those coordinates and talk about what makes the object so interesting to astronomers. So, I will now run the random number generator.
Stop.
The coordinates for this episode are 14 hours, 8 minutes, 10.2 seconds right ascension, and negative 41 degrees, 23 minutes, 53 seconds declination. These coordinates point to an object called PDS-70, which is a reddish protostellar object, or in other words, a star still in the process of forming, located at a distance of 366.6 light-years, or 112.4 parsecs, in the direction of the constellation Centaurus. The star is still forming, but its current mass is estimated to be 0.76 times the mass of the Sun, which means that when it finishes forming, it will probably be very similar to the Sun. PDS-70 belongs to a class of stars called T-Tauri stars, which was named after the star T-Tauri. These protostellar objects are just beginning to emerge from the disks of gas and dust that they form from, but their outer layers are still in the process of collapsing, and they are still surrounded by large amounts of gas and dust. T-Tauri stars are generally found together in molecular clouds and star-forming complexes. PDS-70 itself lies within a region named the Scorpius-Centaurus Association. One way to identify T-Tauri stars is to look for stars that appear to produce too much infrared emission, which would potentially be coming from dust within the disk of material surrounding the protostar. PDS-70 was identified as a potential T-Tauri star in 1992 by people working with data from the Infrared Astronomical Satellite, or IRAS. IRAS was a spacecraft that produced blurry infrared maps of the entire sky in the 1980s, and while almost everything observed by IRAS, including PDS-70, looked like smudges, the spacecraft was still quite valuable for identifying bright infrared objects, and indeed it identified that PDS-70 was a potential T-Tauri star based on the excess infrared emission it produced. In the decade afterwards, multiple other surveys and follow-up observations confirmed that PDS-70 was a T-Tauri star with an extended disk of gas and dust. By the way, the letters PDS in the name PDS-70 come from the Pico d'Ostius Observatory, which was the first telescope used to make some of these follow-up observations. However, PDS-70 turned out to be rather unusual for a T-Tauri star. First of all, multiple follow-up observations, including observations at near-infrared wavelengths with a very large telescope and Subaru telescope, and at millimeter and submillimeter wavelengths with the submillimeter array and the Atacama Large Millimeter/submillimeter array, showed that the disk had a very large gap on the inside. In other words, the disk looked like a flattened ring. This gap has a diameter of roughly 40 astronomical units, or AU, where 1 AU is defined as the distance from the Earth to the Sun. Note that this edge is not really that well defined, but even so, everything in our solar system within the orbit of Neptune would easily fit inside the gap in PDS-70's dust disk. Additionally, in images from the Very Large Telescope published in 2006, an object that looked like a brown dwarf was found orbiting at a distance of 22 AU from the protostar within the inner gap of the dust disk. This brown dwarf was given the name PDS-70b because the International Astronomical Union requires astronomers to give boring names to these types of objects. Brown dwarfs are basically objects with masses between multiple times the mass of Jupiter and 0.08 times the mass of the Sun that are too small to fuse hydrogen and helium in their cores and too large to really count as planets. Although they are expected to be fairly common, they're difficult to find, mainly because they're relatively cool and produce little electromagnetic radiation. So PDS-70 looks like a star system where a brown dwarf is in the process of forming around a larger star, which would make it quite exciting as an astronomical object to study. And that is my summary of why PDS-70 is so interesting to astronomers. Or it would be, except that the initial estimates of the mass of PDS-70b turned out to be way too high. Multiple follow-up observations indicate that PDS-70b is somewhere between 2 and 10 times the mass of Jupiter, which would make it large compared to planets in our solar system, but which makes it much more like a planet than a brown dwarf. So PDS-70b is actually a gas giant in the process of forming. Additionally, it looks like this gas giant has its own disk of gas and dust surrounding it. In other words, it looks like PDS-70b is still absorbing, or to use the technical term, accreting, gas. And some of the leftover gas in this circumplanetary disk might even go on to form moons. This protoexoplanet provides astronomers with a unique opportunity to see how gas giants form and how they affect other objects in the planetary system in which they are forming. And that is my summary of why PDS-70 is so interesting to astronomers. Or it would be, except that another protoexoplanet was discovered in the PDS-70 system in 2019 in follow-up observations of the star system by the Very Large Telescope. This object, named PDS-70c, orbits at a distance of 34.5 astronomical units from the protostar, which places it much closer to the outer edge of the gap in the dust disk. The mass of this second protoplanet has not been very well constrained, but it looks like it's somewhere between the mass of Jupiter and 12 times the mass of Jupiter. PDS-70c also has its own circumplanetary disk, and is also in the process of gaining matter from this disk. So, to summarize, PDS-70 contains 2 protoexoplanets that are still in the process of forming, and both were discovered through direct imaging. Just to emphasize this point, directly imaging exoplanets is extremely rare. Most exoplanets are discovered through indirect methods, such as how they gravitationally interact with the stars they are orbiting, or how the brightnesses of the stars drop slightly when the exoplanets pass in front. Additionally, both PDS-70b and PDS-70c may have very likely been responsible for creating the inner gap in the larger disk of gas and dust surrounding the protostar. Exoplanets have been hypothesized as causing the formation of ring-shaped features in a lot of other protoplanetary disks, but PDS-70 is one of the really rare cases where the exoplanets have actually been found. This system is going to attract a lot of attention from astronomers as a unique example of where exoplanets can be seen in the process of formation, and where those exoplanets themselves are altering the rest of the protoplanetary system. And that is my summary of why PDS-70 is so interesting to astronomers. This time I'm serious. This podcast is going to be published in October 2023, and while it's possible that someone might make another dramatic discovery about the PDS-70 star system sometime later, all I have for now is a protostellar object with a disk of gas and dust and 2 protoexoplanets. The location on the Earth's surface corresponding to the position of PDS-70 in the sky is an area in the Pacific Ocean slightly more than 2,600 kilometers south of the island of Tahiti and slightly less than 2,900 kilometers east of the North Island of New Zealand. It's another random patch of the Pacific Ocean that I can't really say much about. It doesn't correspond to the location of any interesting underwater geological features, and it doesn't lie near any shipping routes. The website for this podcast is www.randomastronomicalobject.com. You can visit the website to download episodes of the show, read information about the astronomical objects, view images of those astronomical objects, look up additional reference information, and send me random feedback. The audio was recorded and edited by George Bendo. The music is Immersion by Sasha Endy at www.sasha-endy.de, and the sound effects are from the Freesounds project at www.freesounds.org. Thanks for listening.